Hello, we are discussing about GATE 2014 ECE paper and the topic is related to analog circuits. Look at the diagram shown. For the amplifier circuit shown in the figure, the BJT parameters are VBE 0.7 volts, beta 200, thermal voltage VT is 25 millivolts. The voltage gain V0 by Vi of the amplifier is V0 by Vi, small signal voltage gain we are going to calculate. Small signal voltage gain whenever you want to calculate, by that time the transistor symbol, this is the transistor symbol, this transistor symbol should be replaced with equivalent model, and then we can calculate the small signal voltage gain. And for the calculation of small signal voltage gain, these capacitors, the microfarad capacitors, act as short circuits and VCC will be treated as ground. So these are the conditions to be known. So whenever we are going for the AC analysis, that is small signal analysis, by that time all microfarad capacitors are act as short circuit and the DC voltage will be treated as ground, because the small signal voltage whatever you apply as the input signal, that doesn't have any effect on the DC voltage. So the effect on DC is 0, so that it can be neglected, otherwise it can be replaced with a ground. Okay, now let us replace the transistor with equivalent model. What are the different equivalent models we have? H parameter model, hybrid pi model, R parameter model. R parameter model or T model. Can we use hybrid parameter model, that is H parameter model over here? Since no H parameter is given, okay, so no value of H parameter is known to us, so we cannot go for the H parameters. What we can go is nothing but we can go for the either T model or R parameter model. And out of that one, the transistor emitter is connected with some resistance of 10 ohms, so that it is better to use T model. Okay, you can go for the R parameter model also, but it will be better if you use T model. The simplification will be a bit easy. So that replace this transistor symbol with T model. So T model is going to looks like this one, where it has a current source and this is collector terminal, and it is connected with, it will be having some internal resistance of Re, and it is emitter, and the base is going to be this one, this is the base terminal. And this current, the current flowing through this one is nothing but IB, and this is beta times of IB you can write, otherwise GMVB also you can write, but we are dealing with current, so that we am going to write it as beta IB. And this is transistor symbol. So now connect the other parameters, of the transistor symbol. Now come from the emitter side. Emitter is connected with RS of 10 ohms, and this Re of 1 kilo ohm is going to be suppressed because of this capacitor. Since for AC analysis the microfarad capacitor and this 1 millifarad capacitor, both we are assuming it as short circuit, so that this will nullify the effect of Re. So Re will not be present. So only 10 ohms will be present for this one, that is what we are writing it. 10 ohms is now connected to ground, as capacitor is acting as short circuit, so this will be at 0 volts. Next, base is connected with input through a resistance of R1 R2 in parallel, so that whenever it is at ground, at that time R1 is from base to ground and R2 is also from base to ground. So looks like both resistors are between the same terminals, that implies nothing but both will be in parallel. R1 and R2 are in parallel because they are between base and ground, so that we can write it as RB, connected to ground. This is RB, that is 33 parallel 11. Now it is not that much important, and this is what the effective input signal what we are applying. And now collector side is connected with RC of 5 kilo ohms, which is connected to DC power supply, but DC power supply is act as ground for the AC analysis. So now 5 kilo ohms is connected from collector to ground, so this is what the situation. So it is 5 kilo ohm and this is V0 plus minus. Now we are going to calculate voltage gain, small signal voltage gain, V naught can be written as minus beta times of by minus beta IB times of 5 kilo ohms. Beta is nothing but 200. So directly we can use it as 200 IB. So V naught is equal to 200 IB multiplied by 5K, which implies nothing but 10 power 3 IB. This is what you will get. V naught is equal to 10 power 3 IB times of kilo. Kilo is nothing but 200 into 5 is 1000. 1000 into kilo is nothing but one more 3 will come. So it will be equal to 10 power 6. 10 power 6 IB. This is first equation, assume. Next, V input. V input can be written as V input is nothing but voltage from base to ground. Voltage from base to ground, and that is nothing but voltage drop across this small RE and capital RE. So across this one, what is the current flowing through this one? One current is IB, which is coming from base. The other current is coming from collector, that is beta IB. So this can be written as 1 plus beta times of IB, and beta is given as 200. So 1 plus 200 is 201 times of IB. So V input is nothing but 201 times of IB into small re plus 10 ohms. This is what second equation. So we can calculate V naught by V in from this equation. IB get cancels. V naught by V input. So IB get cancels. What you will get is 10 power 6 divided by 201 times of RE plus 10. So this is third equation. If you know RE value, then you can calculate voltage gain. That is what the required value of voltage gain. So how do we calculate RE? Okay, to calculate RE value is nothing but RE. Okay, this is nothing but input resistance of a BJT whenever you are looking into emitter with base ground. So RE can be written as VT by IE, where IE is nothing but DC emitter current, VT thermal voltage, IE is nothing but DC emitter current. DC emitter current is nothing but that is the current flowing through emitter whenever no AC signal is applied. Under DC conditions, how much current flows in the emitter? That is called as IE. VT is nothing but it was given as 25 millivolts. So we need to calculate IE, okay, from DC analysis. From DC analysis we need to calculate IE. DC analysis implies nothing but the meaning of DC analysis is nothing but all capacitors act as open circuits. Okay, whenever all capacitors are act as open circuit, at that time this is the required diagram we are going to get. The capacitor act as open circuit, we can remove capacitor act as open circuit, capacitor act as open circuit. Now the effect of RE of 1 kilo ohm has to be considered. So both resistors can be included as 1.01 kilo ohms. One is 1 kilo ohm, the other is 10 ohms. So total it will become 1.01 kilo ohms. So for DC analysis, we are interested in the calculation of IE. So replace this with Thevenin's equivalent circuit at base. So you can write this as RTH followed by VTH, and it is RTH, and this is the transistor with a resistance of 1.01 kilo ohms, and this is connected with 5 kilo ohms plus 12. So VTH, from this one you can write it as VTH is nothing but voltage across R2. This is VTH is nothing but voltage across base. Voltage across base is nothing but voltage across R2. Using voltage division rule, you can write it as R2 divided by R1 plus R2 into VCC, which is nothing but 11 divided by 11 plus 33 into 12, which is nothing but 3 volts. So you will get VTH as 3 volts, and RTH is nothing but 11 parallel 33, that is nothing but 8.25 kilo ohms. So and this is in apply KVL for this loop. Okay, so apply KVL for this loop. Sorry, apply KVL. Apply KVL. Apply Kirchhoff's voltage law at base emitter loop. Okay, so by that time we can write it as VTH minus IB times of RTH minus VBE minus IB, that is current flowing through this one is nothing but IE, that you can write it as beta plus 1 times of IB, which is nothing but 201 times of IB. So you can write it as IB times of 201 into 1.01 kilo ohms is equal to 0. So VTH is nothing but 3 volts minus IB times of RTH is nothing but 8.25 kilo ohms minus 0.7 minus IB times of 201 into 1.01, that is what you will get 0. So IB can be, if you simplify, what you are going to get IB value is 10.9 microamperes. 10.9 microamperes you will get it as IB. From that one you can calculate IE value, that is 201 times of IB. So 201 times of 10.9 microamperes, which is going to be equal to 2.18 milliamperes as IE value. And from that one if you calculate RE is nothing but VT by IE. VT by IE is nothing but 25 millivolts divided by 2.18 milliamperes. So from that one you will get it as 11.47 ohms. And voltage gain AV is equal to V naught by V input is, what you are getting is 10 power 06 divided by minus 10 power 06 divided by 201 times of RE plus 10. So that is nothing but minus 10 power 6 divided by 201 multiplied by RE is 11.47, so it will be 21.47. So what you are going to get is around minus 232. You are getting it as voltage gain. Voltage gain of the common collector circuit given is minus 232. Sorry, voltage gain of the given common emitter circuit is minus 232 is the required voltage gain. Thank you.